So hi everybody, I'm Wade. I'm here to talk tonight a little bit about our approach to authoring Selenium tests using a rendition of the page object model, and I hope to convey how this technique really helps us keep our test space kind of tidy and healthy and very valuable to the company. So to start off with a quick agenda, just to give you a heads up of some of the key areas I'm going to be touching on. I'll go over a little bit of background about our organization and kind of the ecosystem of the applications that we're testing. And I'll talk for a while about some of the core technology choices that we've chosen to implement our testing with. And from there, give you an idea of how we built kind of a bare bones test framework, starting with those technologies, and then how we introduced a page object model to make it more effective and more efficient and resilient. Next, I'll show a few cool tricks that we can do with our tests by utilizing some of the advantages of this page object model. And finally, I'll talk about some supporting infrastructure that kind of helps tie all this together and really make it work well. And then we'll wrap up and I'll open up for questions and answers. So a bit of background about our applications. 95% of our applications are Java-based, and they support a pretty wide variety of complex social interactions. Our product is based off of allowing individuals to interact with their networks in a variety of ways. So we have people sending each other messages and invitations, creating groups, starting discussions, ignoring spammers, all sorts of stuff. And we have a lot of different kinds of users as well. There's the casual users, and then we have kind of premium subscription models, and there are different degrees of separation and connection between different users, which have privacy implications and definitely impacts functionality as well. So we have to accommodate for that, as well as just tons and tons of different pages and states of those pages and transitions between the flows and whatnot. So it's pretty complex to test. Of course, a lot of Ajaxy goodness too. It's always fun. A word about our development cycle at LinkedIn. It's pretty crazy. We have many frequent product enhancements. We're always getting new features and revamping old features, rolling out new stuff all the time, trying to improve engagement and just enhance the value of our products. So a lot of these new features are always developed in parallel. So we end up having sometimes 10, 12, 15 development branches per release. And each of these branches needs to be tested more or less continually. So that leads to kind of a complicated testing environment too. We have to version our tests appropriately along with the code and make sure that none of that gets mixed up. We have a pretty aggressive release cycle, so it's important that we're able to test early and fast and have meaningful results. We also have a lot of testing environments, so probably over 100 QA test environments, a couple of kind of integration and staging environments. And all of these bring their own challenges. Some of them have different configurations, different URL parameters and things like that we need to take into account, as well as different types of existing test data and user sets. We have our QA people embedded basically with development teams. So they're really close to the engineers and product managers. They have a tremendous amount of expert domain knowledge in the products and features that they're testing. And they're responsible, of course, for not only regression testing, but also validating new features and releases on a daily, very frequent basis. So they own thousands of test specs that have accumulated over as our products has evolved. And of course, as someone mentioned in the previous presentation, manual testing is labor intensive and it's hard and error prone. It takes a lot of time and resources. So we definitely want to automate. And our QA team has some pretty mad scripting skills. So that leads to some of the automation goals. We want to automate as much as we can, as fast as possible. And at the same time, we don't want the assets that we create through automation to be just throwaway temporary products. Our goal is to create tests that can be leveraged for a long time to come, and hopefully with a minimal amount of maintenance and work to maintain them and keep their value. We need to be able to keep maintenance costs down, not have to constantly be fixing tests, and and we want to have an environment where tests are pretty easy to pick up and author with speed. The last point here, it might be a little bit confusing. Basically, what it means is that we want our QA personnel to be able to write tests with the desired level of granularity. So they need to be able to interact with with very JavaScript and Ajax heavy areas of pages. At the same time, we do want the test to be easy so that there are a lot of kind of shortcuts and ways to drive a script and just get to the point that you're interested in testing. So the core technology choices that we made, we decided to use Ruby as our primary scripting language, and a lot of this is just that we have some existing Ruby skills within our organization, and we also felt that it's fitting, it's fairly lightweight, and definitely flexible, so that should we need to, we can leverage the flexibility of the language to provide functionality for our test framework. And we chose to use Test Unit, which is Ruby's kind of native XUnit style testing framework, as opposed to something like RSpec or Cucumber or other more, I guess, modern testing frameworks that are pretty popular these days. The reasons are pretty much because it's a simple pattern most people are already familiar with, and it's very straightforward. We write, for a single test case, we have one script that has a setup and a test method and a teardown, so it's easy for us to manage and organize and scale. So the bare bones test framework that we made with these two core pieces of technology looks probably pretty familiar. This is a kind of a common pattern for an XUnit style test. We have a test class which extends some sort of test case base class, and there's a setup function which executes before the actual test. Then we have a test method or optionally multiple test methods, and potentially like a teardown somewhere. One thing I want to point out here in this example is that we use the setup to instantiate kind of a special type of object that we call an environment. And this guy has a hook to our Selenium driver, as well as to a special sort of data collection that is specific to the environment that we're testing against. So for example, it might contain like URLs that we need for the specific QA server that we're testing against. You might have noticed in that last slide, we're just using the plain Ruby Selenium client driver there in that example, which is probably, if you've used any of the Selenium client drivers, you kind of get the syntax. It's fairly straightforward. You instantiate a driver instance, giving it a port and everything, and then you call start on it, which sends a start new test session command to the Selenium RC server. And after that, you can just call methods on it. And for each method, you pass a locator of the element you want to interact with, and some optional arguments. It's a pretty simple syntax. It's verb-oriented, meaning that you call the driver and you say what you want to do, and then the argument is kind of what you want to do that to, which is the element or the locator. It has pretty decent support for Ajax operations, things like it allows you to wait for elements to appear or wait for text to appear on the page, even wait for specific elements to become visible or disappear from a page. And it's pretty well maintained, has a pretty good community around it, so that helps us out. An example of the Selenium client is, this is a pretty simple one, but you can see that we have an instance of the Selenium driver, and we call it click and wait on this XPath element, a couple extra clicks, and then we're doing an assertion to find out if an element is present. So while this is a perfectly valid piece of code, and it works, and it accomplishes the goal of driving the browser and then asserting something about the DOM, it's just looking at it here is a little bit, it can be tough to follow if you're just jumping into an old test or you're trying to fix a broken test, which is kind of one of the, I think, major challenges in web testing, is keeping the tests sane and readable and understandable, clean. So especially, somebody also mentioned in the Q&A section before about, why use XPaths when you can use link text or IDs. And I think in an ideal world, we would use pretty much IDs for everything. I do want to say we can't necessarily rely on link text because we might want to run our tests against an interface in a different locale or a different language, so that the link text might change. But there are other reasons too when you need to use XPath or CSS locators, just based on the markup of the sites that you're testing. If you had if a testing team has a very good relationship with web development, or if they're the same people, it can be easy to establish your markup in such a way that's easy to hook into and test and drive very simply by just referring to IDs and such. But in an environment where you have a lot of testers and maybe not as close a relationship as would be desired, and there's a lot of change going on, it can be pretty much impossible to keep up with just IDs. So a continuation of the previous example. This is actually the same code, but just with some comments added. So in our first iteration of this test framework, when we were using just kind of the bare bones Selenium driver, we made sure to use liberal comments just so that we could kind of keep track of what we're doing in our tests. So that helps a little bit, but it still leaves some problems.